demos that I'm going to do before we get into light waves. We're going to focus on light color, which when we talk about light waves, I want to emphasize this. Actually, in the back of your packet, you've got the electromagnetic spectrum. All of these waves, whether they are visible or invisible, are light waves, like the microwave. You can't see it, but that is a light wave, believe it or not. Now, there's only a tiny portion right here in the middle between infrared and ultraviolet. That tiny little portion is the portion of light that we can actually see. It's very small. There's so much more of the electromagnetic spectrum that we cannot see. But what I'm going to focus on just in this little segment before you start working on your project is the visible light. So we're going to start off with a little video. And I want you to really try to observe some of the things that she's asking you to observe, because light can kind of play with your mind a little bit. And it's really fascinating to see the effects of light when she talks through some of these demonstrations. So this is Physics Girl on white light.
I want you to stare. Really focus on the circle at the center of this group of dots and don't move your eyes. Do you see it? If you're not colorblind, it's likely you're seeing a blue dot moving around the circle. Try looking at the blue dot and you'll find it's not there. Why would your brain tell you something's there when it's really not? Well, the shocking truth is that this happens to you every day, especially while you're staring at your computer or phone screen. So in here I've got some red and what's the other color? Green. Pass the first test. And I'm gonna have you mix it up. What color do you think it's gonna turn?
Probably the second grade, I should remember this, but it should be yellow, right?
Red, brown, orange?
Purplish.
Purplish. Okay. What is it looking like? Brown? Dark red? Alright, what color is it turning?
Greenish brown.
I've got the same colors, the same paint actually. And I'm gonna spin it. What color do you think it's gonna appear?
Brown, but I think this is a trick question.
Okay, so you're gonna say brown again. You're gonna guess brown.
I know it's wrong. It's a trick question. It has to be.
I hope this one's yellow and not dinky brown.
Okay, you hope this one's yellow. What color does that look to you?
Oh, it's yellowish.
It's like a yellow, like a mustard yellow.
Like a mustard yellow. Was it surprising that this kind of dark red and that bright green made yellow?
Yeah, I'm just trying to think of why.
Why was it happening? You're told in art class that when you mix the three primary colors, red, yellow, and blue, you get brown. And that's true of paint. But it's not true of light. When I spin the red and green wheel, there's no yellow light there, but you see yellow. Your brain is being tricked because of how your eyes work. On your retina, you have light-sensitive cells called cones that perceive color. Red light, green light, and blue light cones. Some people have an extra cone, which would allow them to see many more colors than the rest of us, which would be crazy. But typically we just have the red, green, and blue cones, which means that there's no cone for orange light or yellow light. But the crazy thing is that these three cones work together to allow you to see the rest of the colors. It works like this. If I shine the yellow light on your eyes, your red cones actually respond a little bit, and your green cones respond a little bit too. Then your brain combines those red and green responses to say, that's yellow. Now, if instead of yellow light, I shine a little red light and a little green light on your eyes, the red cones respond and the green cones respond, and your brain says, red and green. Well, that makes yellow, even if there's no yellow light there. This is how your LCD screen tricks you into seeing yellow. It's doing that right now. All you're seeing with your eyes is red and green, but your brain is seeing yellow, and now blue, if you stared long enough at that yellow star. This is an effect of how your eyes work as well. And so were the yellow dots at the beginning. They have to do with complementary colors. But don't get this confused with complementary or opposite colors on a paint color wheel. If you mix two of those opposite colors, you get a darker brownish color, because adding more pigments means more colors are absorbed. On a color wheel for light, mixing two complementary colors gives you white. For example, if I show you this red screen and then this cyan screen, and then switch them back and forth fast enough, you should see white. Here goes.
Do you see it?
I really hope that worked. And if it did, you'd be making this face because it's incredible. You mix two colors and you get white. But white is all the colors. Or you perceiving all the colors. If I shine red, green, and blue light on your eyes, you're gonna see white. Because white light excites all three cones, just like a mix of red, green, and blue light does. Otherwise, this wouldn't look white with just the red, green, and blue pixels on your RGB screen. So, red mixed with its opposite color, cyan, which is just a mix of green and blue light, should look white. And now, you'll notice that blue is the complementary color of yellow, so together they should make white. When you stare at yellow light for a while, your red and green cones continue to respond and eventually become dull. When you suddenly switch to a white screen, all three cones should now get excited. But blue was the only one that wasn't dulled over time, so it will send a stronger signal to your brain, and your brain will tell you there's blue light, even when there's not. But now, you know better.
All right, so first, did anyone see the dot as that dot was moving? Did anyone see the blue dot appear? How about when it was flashing, the red and the blue? Did you see white? I see a few hands, so. I saw white most of the time, and then I saw a flash of blue and a flash of red. So, what I want you to, Brady, can you turn the lights on for me? What I want to point out is that light, actually, I'm going to have you turn them off in a second. Light colors are opposite of paint colors. How many of you are artists? Take our class. Oh, come on, I know there's more of you. I see all the drawings on the corners of my paper. The point is, it's hard to believe that red and blue can make white because those are such bold colors. But in light, that's what happens. So I've got red and I've got green. If I combine those together as paint, they made like a reddish brown, right? If I combine them together as light, what color do they make? Yellow. So then how about red and blue? Those make what we call magenta. That's a secondary color. And then if I do blue and green, they make a light blue, which we call cyan. So those are the secondary colors of light. If I mix all three together, what do you see in the center? It's white light. So combine all the colors. RGB are the primary colors of light. If you combine them all together, you make white. If you take away all those colors, you get black, which is the opposite of paint, right? If you have no paint pigmentation, you get white. If you combine them all together, you get a really, really dark brown or close to black. The other thing I wanted to show you before I turn the lights on again. Okay, so I've got my ball lit up, and I mean, you kind of see a bunch of colors, but in general, what color is it? There's a little red, but mostly white, right? Okay, if I spin it, what do you see?
Rainbow.
Rainbows, but what specific colors of the rainbow? RGB, the primary colors of white light. So she mentioned this. For those of you who are thinking TV as a wave technology, TV uses the RGB screen. They use RGB pixels because those three primary colors will give you all the colors that you need to see every color of the rainbow. So very different from paint colors. Let's see if I can escape this, get back to my slide deck. So the way light works, especially when you are out in the sun, you've got white light, and the white light has all the colors of the rainbow. When you see an image, for example, you see blue or you see red, that is because the object that you are looking at is absorbing all the other colors except for the blue. That's what bounces off of the object, and that's what you see in the object itself. So when I'm looking at a green leaf, it's because that green leaf is absorbing all the other colors of the rainbow, and it is reflecting that green light. So it really depends on the light that is striking it. What I wanted to show you, and I'm not going to go into detail, is that a black object will absorb all the light, all the colors of the rainbow, so you don't see anything, you see black. And then if I had a white object and I shined red light on the white object, because that white object will reflect all the colors, I'm going to see red. If I had a red object and I had white light projecting on it, I would see red light bouncing off. Okay, I'm not going to get into refraction. We're going to do another demo, more demos next class on refraction. I do have one demo, but it's a really cool demo that I was able to set up today. I've got a candle inside a beaker. This is a little bit of reflection. You can kind of see the reflection of that light as it hits, but here's my candle in the beaker. And when I touch the fire, I don't get burnt. In fact, since it's in a beaker, what's going to happen if I pour water over it? It's hard to do when you can't see what you're seeing. What's happening? It's not in the beaker. I can even switch it around. Light's not moving.
Wait, is it still on fire?
Is the light still on fire? What's happening?
It's just not.
It's a reflection of the rainbow.
It's an optical illusion.
It is an optical illusion. It is not in the beaker.
For all intents and purposes, we'll just say that it's on fire.
It is the reflection of a candle outside on fire. So this is reflection. We're going to talk about reflection later, but it took me so long to figure out how to make this work, and my first and third didn't get as great of an effect as you did. But this is what's used in the Haunted Mansion. When you see ghosts next to you, you're seeing a reflection of that ghost. So pretty cool, right?